Alrighty, friends, we are going to tackle something called complex numbers, and they are not actually that complex. They're a little bit weird. I don't know if you've done this in the past, but we're going to be introducing something that's called an imaginary number. And it's an unfortunate name because it's not really imaginary, but we have the real number system, and then that's what we always operate in. But then there's this thing called imaginary numbers, which allows us to take the square root of a negative. So somebody in their infinite Saturday night wisdom decided, hey, if we let I represent the square root of -1, then we can take the square root of negative numbers. But I squared turns out to be -1. These are kind of the two building blocks behind what we're going to be doing. And the reason that's true is if you square I, which is the square root of -1, the square and the root cancel, leaving you with that -1. So these two fun facts are definitely going to be essential to what you're doing from now on. And I skipped the thing that says complex numbers. A complex number is simply a combination of real numbers and imaginary. So you're going to have a real part, meaning regular old numbers that we usually use, and then you're going to have either added on or subtracted from an imaginary part. So it has both a regular part and then a number with I. So the form that it comes in is something and then either plus or minus something I, where this is the real part and this is the imaginary part. But it's not really imaginary, like an imaginary friend. It's just called that, which is unfortunate. Now we're going to spray my dog because she's eating her dog bed. Hang on. Oh, she just went to sleep instead. Good girl, Dolly. So what does that look like? That looks like this. If I had a square root of 36, that would be great. But I have a negative in there. So you can think of it as separating out the negative if you want to. Square root of 36 would be 6, just like it's been the rest of this week practicing. And then now we just learned right up here that the square root of -1 is I. So the answer to that is 6I. And I always say that the I indicates that there was a negative under the radical. So one mistake that kids make is once we do this, they put I's with a bunch of their answers. You only have an I in your answer if there was a negative under the radical. So up until now, we would have done this using our blue card and our perfect squares. I'm just separating out the -1 because -1 and 50 would certainly make -50. Then my blue card helps me find the biggest perfect square that goes into 50. And then I can go ahead, I've got a 2 out front. This becomes a 5. This we just learned is I. And this is just kind of stuck. But 2 times 5 becomes 10. So I have 10I out in front and a root 2. Because you can't have a negative under the radical in your answer. So you have to get that I out of there to get rid of the negative. So what about this? This is taking 7I times 7I. What I always think about is that I'm going to treat, when I'm doing my math, I'm going to treat I like an X until it's squared. So you can square X and leave it in your answer, but you can never have X squared in your answer. So maybe write yourself a note about that. Never. So you never want to leave an I squared in your answer. And the reason is that it has a number value. We learned right over here that it's a -1. So what I mean by treating it like an X is if I had 7X times 7X, I would know that that's 49X squared. It's no different down here. 49I squared. What's different is that since I squared has a value of -1, that becomes a -1, and then my answer becomes -49. So I check my answer and make sure I don't have any I squareds. Now we're just doing more math. And again, treat it like X. If these were X's, you would just distribute this negative, which that alone can be kind of tricky. That'll turn into -3 and a +6I, just because negative times a negative turns positive. But now what you do is you put all the real parts together. So the 7 and the -3, they become a 4. And then normally I would put all of the imaginary parts together. Problem is, this is a -6i and this is a positive. So in this particular problem, they cancel out. So my answer is just a 4. There ends up not being an imaginary part in that answer. Here, you know what to do with this. You distribute. So these would multiply to become -24i, just treating it like it's an x, and this would become a positive 4i squared because it's getting multiplied by itself. Okay, so I really can't do anything here, but here I squared has a value of -1. So I end up with this. But technically, the real part is supposed to go out front, and then your imaginary part goes next. So again, you don't leave an I squared in your answer. So when you get an I squared as a part of a problem, a lot of times in foiling that happens, that I squared gets replaced by a -1, and then it can go ahead and multiply by whatever number it's attached to. Okay, not surprisingly, this is going to be a FOIL, so I'm going to do the first terms and get -36. Then I'm going to do the outside and get +63i. Then I'm going to do the inside. The negatives cancel and become positive, 8i. And then I'm going to do the last two terms. -2 times +7 is -14. But I times I is I squared. As soon as you see that I squared, you think, okay, I can't leave that in my answer. Because it's like having a -1 gets multiplied by the -14 and becomes a +14. That +14 is now just a part of the real numbers. So I can put it together with my other real number of -36, and I'll get -22. And then here, because these are both i's, just like with x's, 63x plus 8x would go together. 63i plus 8i goes together and becomes 71i. So I always have my real answer part out front, my imaginary answer part second. But if you kind of live by this and do your math, treating I like it's an x until it's squared, then you're good to go. And when it does get squared, you replace it with a -1 and then multiply by the number that's with it. So this is kind of the basic beginning complex number / imaginary stuff. So hopefully that will help you out.